To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello dear grade 7 children. Today we are going to learn the 11th lesson of the science textbook, that is sound. Now this topic you are very familiar with because even last year we learned about sound as a type of energy. Right children? Even this year we learn about the sound as a form of energy, and we even learned that what are the instances we can use the energy contained in the sound in our day-to-day lives. So under this lesson, we are going to learn more about sound. So let's see what are the topics that we have to discuss. Right. So we have to discuss this topic, this lesson under two main topics, that is production of sound. Even last year we learned about production of sound, how sound is produced. We learned briefly about the first topic. Now under the second topic, we are going to learn about the propagation of sound. What is the meaning of propagation, children? Propagation means transmission or moving or traveling of sound waves from one place to another place. So this lesson, we are going to learn under these two main topics. Let's start the lesson. Right. So our first topic is production of sound. So when we discuss this topic, do you remember what are the topics we learned under the sound lesson last year, children? We learned how sound is produced, and we learned that when we discuss about sound, there are two main types of sound. What are they, children? Natural sounds and artificial sounds. Right, children? And further we learn about based on the way the sound is produced, there are other two types, that is music and noise. So under music, we learned that music means a certain sound waves with a certain pattern, with a rhythm. And we further learned that music is pleasant to the ears. And at the same time, we learn noise means unpleasant sounds. These type of sound waves don't have a specific pattern or a rhythm. Therefore, they are unpleasant to your ears. Right? So production of sound. We hear various sounds frequently in our day-to-day life. Now, basically, there are two main types of sounds as natural and artificial sounds. Let's write some examples, children. You all can start before me because we are familiar with this lesson, right? Okay, first I will write some natural sounds. Natural sound. Right? What are the examples, children? Birds chirping, dogs barking, the sound of leaves rustling, right? Water flowing, the sound of water flowing, wind flowing, those type of sounds we can write. Human speaking, natural sounds. Birds chirping, dogs barking, leaves rustling, you can write many other examples. Let's write some examples for artificial sounds as well. What are the artificial sounds, children? Artificial sounds. What are the examples, children? We can write the school bell ringing, right? School bell is an artificial object. So objects, so the sounds made by artificial objects are known as artificial sounds. Right, children? We can write the school bell ringing. School bell ringing. Vehicles moving, when vehicles move, and the honking of vehicles also artificial sounds. Sounds of machines, right? We can write them. sound of vehicles, sound of machines, so you can write many other examples under this. I wrote only a few examples, right? But when you write these examples, you can make your list longer. Right, children? We'll move on to the next. Right. We have our first activity under this lesson. The activity is finding out about the sounds we hear. Right, children? So to do this activity, we need a small speaker like this. We need some styrofoam balls or polystyrene balls, which we know as Rigiform balls. They are very light in weight. And we need some connecting wires and dry cells, right? Let's write a speaker, polystyrene balls, two pieces of wire, dry cells. Right? A speaker, polystyrene balls, connecting wire and dry cells. Okay? Let's see how to do this activity. Right. Look at the diagram. This is the speaker. The diagram is labeled. So you have to place the polystyrene balls on the speaker. Right? And the two terminals of the speaker should be connected with the pieces of wire, and one wire should be connected to one end of the dry cell. From here, the other wire end should be kept open. Right? Let's go through this. Connect the wires to the terminals of the speaker. Place the pieces of polystyrene balls on the speaker. Right? Connect one of the two free ends of wires to the dry cell. Then what do you have to do? This end is opened, right? The next step is touch the other free end of the wire with the other terminals of the dry cell and remove them at once, right? Touch the other free end, which is this free end of this blue color wire, right? Touch the other free end of the wires with the other terminal, right? Of the dry cell and remove them at once. You have to touch these two ends and you have to quickly take it off and observe what happens to the polystyrene balls, okay? Do not keep the wires connected to the dry cell. You have to do this on and off, right? Keep on touching and removing one end of the wires to the dry cell and record your observations. Let's do this activity now. Right, children? Now we are going to see how sound is produced. Now look what I have. I already explained you all how to do this activity, right? Look what I have. Here I have a speaker cone. And you all can see it is connected to this 9-volt battery, right? But at the same time, you all can see it is connected only from one side. See, two wires are coming from this battery and only one wire is connected here. Right? From the other end, it's a free end. Right? They are not connected. And at the same time, here I have small Rigiform balls. Okay, children? Right. Now to do this, start this activity, I'm going to place these Rigiform balls on the speaker cone. Right. So what happens, children? Nothing happens. Can you see them moving? No. Any other kind of movement? No. You can't see them moving. Right? Now observe carefully what I am going to do and listen carefully as well. Look and listen, right? Now what I am going to do is the other end of this wire I am going to connect with this small wire the other wire coming from the speaker cone. Look and listen what happens. Can you hear the sound, children? Right. Listen carefully. As I connect these two wires, you all can hear the sound of the speaker. Right. So whenever you hear the sound, what happens to these rigiform balls, children? They move up and down. Observe carefully now. This happens only when I touch these two wires, right? Only when these two wires are connected, you can see both the observations, right? Watch again. Right. You all can see they are moving when I touch these two wires together, right? Now when they are separated, when they are not connected, can you hear the sound? No. Can you see these rigiform balls moving? No, right? Okay, children? Right. Right, children. What is the reason for these observations, children? Now remember, initially only from one side, this speaker is connected to this battery. Right? So you can't see any difference here. No sound, no movement of the rigiform balls. Only when we connect these two wires, you can see these observations. So what happens, children? When I connect these two wires together, what happens? Electricity starts to flow through this speaker cone. Because of the electricity, this speaker cone, this small part vibrates, and at the same time, because of that vibration, sound is formed, right? Sound produces because of these vibrations, right, children? So along with this speaker, base of this speaker part, as it vibrates, as it moves, what happens, children? These small pieces of rigiform balls also vibrate up and down. They also move up and down, right, children? So only when electricity is supplied, these observations are possible, right? So which means, what is the conclusion that we can come up with? When electricity flows through this circuit, flows through this speaker cone, what happens, children? The speaker base, the speaker part vibrates. According to the vibrations, these rigiform balls also move up and down. And because of these vibrations, sound is also produced. Right, children. So you all observed what happened. What happened here, children? Here, when we touch this wire end, this other free wire end with the dry cell, what happens, children? These tiny polystyrene balls start to move up and down. That happens only when this connection is there between the wire and the dry cell, right? When we take the wire end off again, the movement stops. Right, children? When we supply electricity again, when we connect the wire again to the dry cell, they start to move up and down again. So what is the conclusion that we can come up with, children? So when we supply electricity, when we connect this wire end to the dry cell, electricity flows through this circuit, right? Which means electricity is supplied to the speaker. So in that moment, the speaker surface starts to move. This type of movement, this up and down movement, is known as to and fro movement, right? So when this speaker surface moves to and fro, what happens? Accordingly, as the polystyrene balls are also placed on the speaker surface, these tiny polystyrene balls also move, right, children? So this type of to and fro movement is known as a vibration. Okay, so it's clear that sound is produced by vibrating surfaces or objects. Okay, let's write observation. The polystyrene balls move up and down only when the wire is connected to the dry cell. Right, children? The polystyrene balls move up and down only when the wire is connected to the dry cell, right? Which means only when the wire touches the dry cell, right? So what is the conclusion? When electricity is provided, the surface of the speaker moves to and fro. According to the movement of the surface of the speaker the polystyrene balls also move. When electricity is provided, the surface of the speaker moves to and fro. According to the movement of the surface of the speaker, the polystyrene balls also move. Right, children? Okay. So here, look at the same thing is given again. It is observed that pieces of polystyrene are thrown up only when the speaker is connected to the dry cell, right? It means that pieces of polystyrene are thrown up only when the speaker produces sound. So when we connect this wire to the dry cell, speaker to the dry cell, what happens? Electricity passes through the circuit, through the speaker, and the speaker produces sound, right? So when the speaker produces sound, that polystyrene balls start to move up and down, right? This happens because of the to and fro movement of the speaker cone, the surface of the speaker, right? Which means when the speaker produces sound, what happens? This movement of the speaker cone, to and fro movement of the speaker surface can be seen, right? This type of speedy to and fro movement is known as vibration, right, children? So it's after going through all this, it's very clear that sound is produced because of the vibration of the speaker surface, right? When we provide electricity, the speaker surface starts to vibrate. Because of that vibration, sound is produced. So because of that vibration and the sound produced, the tiny polystyrene balls also start to move. Right, children? Okay. So it's clear that sound is generated due to the vibration of an object. Right? This is very important. Sound is generated due to the vibration of an object. Right? So this is how sound is generated. So this part actually we learned even in grade 6. I hope you all remember. We learned that we did different other activities to study this one. Do you remember? We kept some tiny pieces of paper on a small drum, the rabana, and we tapped on the skin of the rabana. What happens, children? The tiny pieces of paper, they start to move up and down, right? The same type of observation, right, children? So therefore, now we know that sound is generated due to the vibration of an object. Let's move on to the next. Right. We have another activity to do. So finding out more about the generation of sound, okay? So what do we need to do this activity? We need this instrument called the tuning fork. Now this is a metal instrument. It has two arms like this and a handle. Okay, so this is called the tuning fork. Let's write. So tuning forks come in different lengths, okay, different sizes and different lengths. This is a tuning fork. We need a tuning fork and we need a laboratory stand. Laboratory stand, and we need a piece of thread. A piece of thread and a polystyrene ball. Right, children? We need a tuning fork, a laboratory stand, a piece of thread and a polystyrene ball. Right. So what is the method? So you all can see this is the setup. We'll label this one as well, the laboratory stand. This is the laboratory stand, the thread, tuning fork and the polystyrene ball. Laboratory stand. Right, children? So what is the method? Hang the small polystyrene ball using a piece of thread as shown in the figure. You have to pass the thread through the polystyrene ball and hang it on the laboratory stand. Okay. Then what you have to do is vibrate the tuning fork and bring it close to the polystyrene ball. How to vibrate the tuning fork? Now, before you vibrate the tuning fork, you have to just bring it without vibrating. You have to first just bring it closer to the polystyrene ball. So you will observe nothing will happen to the polystyrene ball. Now you have to vibrate the tuning fork. How to vibrate the tuning fork, children? So you have to hold it from this handle and you have to hit the other like two arm-like parts harder on a rubber surface. There are special rubber pads to do this, or any other rubber surface also can be used. Okay, you have to hold from this handle part and these two arm-like parts, you have to hit harder on a rubber surface. So then what happens? This starts to vibrate. When it vibrates, a small sound also will be heard. Okay, children? Then vibrate the tuning fork and bring it close to the polystyrene ball. It should not touch the polystyrene ball. You have to just bring it close to the polystyrene ball and hold it closer. Right? Observe what happens. And you can repeat this several times. Let's do this activity now. Right, children. Now we are going to learn more about generation of sound. Okay? Now here, in order to do this activity, as I explained you all before, here I have a small rigiform ball hanging on this laboratory stand. Okay? And look at these objects, children. What are these? These objects are known as tuning forks. Look at the objects carefully. There are different size tuning forks. Right? So I'm going to use one of these tuning forks to do this activity today. Right? So when we consider this tuning fork, you all can see here, this is the shape. And there's a small handle to hold this properly. Right? So these type of tuning forks are used in the laboratory to do different activities related to sound. Okay. So first of all, I am going to bring this tuning fork towards this tiny rigiform ball. See what happens. What happens? Can you see any difference? Any change takes place in the rigiform ball? No, nothing happens here. Right? Nothing happens here. Right? Now I am going to vibrate this tuning fork. These arm-like parts I am going to vibrate and bring it towards the rigiform ball again. Right? Now here also when I vibrate this one, you have to listen to the sound produced. Right? You will hear that a certain sound is produced when I vibrate this tuning fork. And at the same time, you can see the other change takes place in the rigiform ball when I bring this vibrated tuning fork closer to the rigiform ball. Okay, right. So I'm going to use this object to vibrate this tuning fork. Listen carefully what happens. Right, children. Could you hear the sound? Right? When I strike this tuning fork on this object, what happens, children? These two arms start to vibrate. Right? When I vibrated this one, did you hear the sound produced? We'll do this activity again. Right. So I hope you heard it very well. Now as the second step, what I'm going to do is, I am going to bring this after vibrating the tuning fork, I am going to bring it closer to the rigiform ball. Observe carefully what happens, right? Right, children. What happens this time, children? This rigiform ball moves towards and away from the rigiform ball. Right? Watch again. So you all observed what happened earlier. Now this stopped vibrating. Now again I am going to bring this closer to the rigiform ball. Nothing happens, right? So only when I vibrate this tuning fork, you could hear the sound. And also when we brought the vibrated tuning fork towards the rigiform ball, what happened, children? It started to move to and fro, towards and away from the vibrated tuning fork. What is the reason, children? Now when I strike this tuning fork on this object, what happens, children? It starts to vibrate. Because of the vibrations, what happens, children? The sound is generated, the sound is produced. You could hear the sound very clearly. Right, children? And at the same time, when I bring this vibrated tuning fork towards the rigiform ball, those vibrations spread through air towards the rigiform ball. The air particles move because of the vibrations. So along with the air particles, as these vibrations spread through air, what happens, children? Because of the vibrating air particles, this rigiform ball also starts to vibrate. Right, children? So after doing this activity, it's very clear that sound is produced because of vibrations, and these vibrations can spread through air as well. Right, children? So you all observed what happened in that interesting activity. So what did we do, children? First we brought the tuning fork without vibrating it towards a polystyrene ball and we kept it closer. Nothing happened. Then for the second time, we vibrated the tuning fork and brought it closer to the polystyrene ball. Then what happened? This polystyrene ball started to move to either side. Right? So why does this happen, children? When we vibrate the tuning fork, what happens? A small sound also produced. Right? And then what happens? When we vibrate the tuning fork, this vibration spreads through the air particles, right? So even though we can't see in between this polystyrene ball and tuning fork, there are air particles. Then what happens? When we vibrate the tuning fork, it vibrates these air particles also. Through air, this vibration spreads, right? So it moves these air particles, it vibrates the air particles. Because of the vibration of the air particles, these polystyrene ball also moves. That is the reason. Right, children? So when the tuning fork is vibrated, what happens? Air particles also vibrate. Okay, that is why the polystyrene ball also moves. Right, children? Let's write. Right, observation. When the tuning fork was brought towards the polystyrene ball without vibrating, nothing happens. Right? Then, when the vibrated tuning fork was brought closer the polystyrene ball, starts to move. Right, children? When the tuning fork was brought towards the polystyrene ball without vibrating, nothing happens. When the vibrated tuning fork was brought closer to the polystyrene ball starts to move. Right? Let's write the conclusion also. Now we discuss the reason for this one. When the tuning fork is vibrated, sound is produced. This vibration spreads through air near the polystyrene ball, and due to this movement, the polystyrene ball also moves. Right, children? When the tuning fork is vibrated, sound is produced. This vibration spreads through air near the polystyrene ball, and due to this movement, the polystyrene ball also moves. This is the main reason, and after this we can come to a conclusion that sound is produced by vibration of objects. Right? Now here, when we vibrate the tuning fork, a sound is also produced. Right? Sometimes we can't hear this sound very clearly. Right? So when the tuning fork is vibrated, sound is produced. So it's very clear that sound is produced by vibration of objects. Okay? Sound is produced by vibration of objects. Right, children? Sound is produced by vibration of objects. So we have another activity to do. It's also a very easy activity. We can do it now itself, right? Finding out how our vocal sound is produced. So when we talk, sound is produced, we are going to find out how our vocal sound is produced. This is a very easy activity. You all can do this now itself, right? So place your fingers on the middle of your throat as shown in the figure, right? So Next one, speak slowly and record what your fingers feel. Now start to do this activity, children. You all can, while watching this, you all can start to do this activity. Right? Place your fingers on the middle of your throat. Now in your lower grades, you must have learned that here we have something called sound box. Now in your lower grades, you learn it as sound box. But in the upper grades, you all are going to learn the name of this. The scientific name of this sound box is larynx. Because we have the larynx somewhere here on our throat, we can produce sound. Okay? So place your fingers on the middle of your throat as shown in the figure here. Right? Speak slowly and record what your fingers feel. Do it now. What do you feel, children? Right? Then speak louder and record the feeling on your fingers. What happens then? Now when you speak slowly, you can feel that a little vibration, the trembling to your fingers. But when you increase your volume, what happens? When you speak louder, what happens to that trembling? Trembling also increases. Right? You can feel it very well. Okay? What is the reason for this one, children? Here, we have special structures in our larynx called vocal cords. So when we speak, what happens? These vocal cords vibrate. So we can feel this vibration of the vocal cords as trembling to our fingers. Right, children? So that is why when we speak slowly, the vibration is less. That's why we feel slight trembling to our fingers. Right? But when we speak louder, what happens? These vocal cords vibrate faster. Right? We can feel that intensity as well. Right, children? So let's write this one. Right. We will write this. A slight trembling is felt when talking slowly. The trembling increases when talking louder. What will happen if you don't talk and still keep your fingers on the throat? Just try to do that. You can't feel any trembling, right? The trembling stops when we stop talking. Right, children? A slight trembling is felt when talking slowly. The trembling increases when talking louder. The trembling stops when we stop talking. Right? So what is the conclusion? Right. The trembling is felt due to the vibration of vocal cords in the throat. Due to the vocal cords. Right, children? Vocal cords in the throat. Therefore, the vocal sound is produced. Therefore, the vocal sound is produced due to the vibration of due to the vibration of the vocal cords. Right, children? The trembling is felt due to the vibration of vocal cords in the throat. Therefore, the vocal sound is produced due to the vibration of the vocal cords. Right? When the vocal cords vibrate, we can produce sound. Right, children? Let's move on to the next. Right, here the same thing. A light trembling is felt in the fingers when speaking slowly. This trembling increases when the voice is increased. This type of trembling is felt because of the vibration of membranes in the throat, which are known as vocal cords. Vocal cords. That means our vocal sound is produced because of the vibration of vocal cords in the throat. Our vocal sound is produced because of the vibration of vocal cords in the throat. Right? So the sound is produced because of the vibration of an object. Now here, the vocal sound is produced because of the vibration of vocal cords. Right, children? Okay, we have this assignment to do. Design and carry out simple activities to show that sound is produced by vibrations. You all can try to do these type of activities. We have now last year and even this year we have done activities related to this. Do you remember what were the activities that we have done last year to show that sound is produced by vibrations? Do you remember? Even earlier I explained you during this lesson. You have to take a small drum. This is known as rabana. And what you have to do, you have to place a small pieces of paper, or you can even place small polystyrene balls on the membrane of the rabana, on the surface. Right? We will label this. This is the drum skin or the membrane of rabana, small pieces of paper. This is the small drum. Small or light pieces of paper. Pieces of paper. So what do you have to do here, children? When you tap on the small drum, lightly, what happens? Small pieces of paper move up and down. When you increase the tapping, when you tap harder, what will happen, children? The small pieces of paper moves faster. We did this activity. So using this activity, we can show that sound is produced by vibrations, right? Because of the vibration of the drum skin, small pieces of paper also vibrate, right? What is another activity? Do you remember? Last year we did another activity. We vibrated the bell cover, bicycle bell. When we vibrate the bicycle bell and you can touch the surface lightly. What do you feel? You can feel your fingers trembling, right? Why does that happen? So when the bicycle bell rings, that bell cover also rings and the metal surface vibrates, right? Metal surface vibrates. Now here you can do it in another way. You can take an electric bell setter and you can place again pieces of paper here. And you have to provide electricity to this electric bell, and then what happens? When you provide electricity, this bell will start to ring, and when it rings, these tiny pieces of paper vibrate. Right, children? This is another example. Another activity you all can do. Okay? So here what happens? When electricity is provided, sound is produced by the bell, and because of that one, vibration takes place, and then what happens? Small pieces of paper also vibrate. Right, children? So by that one also we can prove that sound is produced by vibrations. Do you remember in the 7th lesson we did another activity? What we had to do was we had to take a radio. We had to take a radio and on the speaker of the radio. You have to keep the radio like this as if its speaker turns up, and then you had to place a piece of paper on the speaker and then place tiny rigiform balls on the paper. Then what happens when electricity was supplied? So when you turn on the radio, what happened, children? These tiny rigiform balls started to vibrate. Right? When you increase the volume, what happens? This movement of moving, like the to and fro movement, increases. They move faster. Then again you turn down the volume, what happens? Their movement slows down. Right, children? This also happens when we turn on the radio. Vibrations take place and sound is produced. Because of that vibrations, what happens? These tiny pieces of paper or tiny rigiform balls also vibrate. Right, children? So you can design these type of activities, right? Design and carry out simple activities to show that sound is produced by vibration. So we have discussed all these activities before. So you all are very, very familiar with this topic. Right, children? We'll move on to the next. We have another activity to do. This is also a very, very easy activity. We have done these type of activities also last year. When we discussed about different musical instruments, we did some activities related to this topic, okay? Instruments that produce sound. Now already you all know that there are main types of instruments based on the way they produce sound, based on the part that is used to produce sound, the part that vibrates, okay? This is related to that. So what are the materials we need? We need different types of musical instruments. Here I am going to use only 3 musical instruments, but then you can use the other musical instruments as well, right? Here I am going to use a guitar, a small drum, and a flute. Right, children? So what you have to do is produce sound using the sources of sound that you are provided with. You have to make sounds using the musical instruments that we have. Observe the part of the sound source that vibrates when sound is produced. Right? Observe the part of the sound source that vibrates when sound is produced. Okay, which part vibrates in order to produce sound, which part we have to vibrate. We have to observe that carefully. Right? Tabulate your findings. Let's do this activity now. Right, children? Now we are going to learn how different types of musical instruments produce sound. Now here I have 3 musical instruments here. I have a small drum, and here I have a guitar, and here I have a flute, right? Okay, first I will take this small drum. So you must have seen there are different types of drum. How do we play the drum, children? How do we produce sound using the drum? You all are very familiar. When you're small, you must have used these type of small drums, the toy drums as well. Okay? You all know that there's a drum skin like this, right? Or this is known as the membrane. So what do you have to do in order to produce sound using the drum? Here. What do you have to do? You have to vibrate this skin. Now you all know that sound is produced by vibrating certain particles or certain object, right? So which part should be vibrated in order to produce sound, children? It is the membrane. When it comes to different types of drums, it is the membrane. Right, children? So all the musical instruments that are made by using a membrane, in order to produce sound, we have to vibrate the membrane. Okay, children? So the stretchness of the tension of this membrane can be increased by these special type of parts, right? We can make them tighter, right? You all can see there are different types of strings that we can make them tighter, and we can increase the stretchness of the membrane. Thereby, we can change the type of the sound produced. Okay, children? Right. So, now you all know when it comes to different types of drums, drums produce sound by vibrating membranes. Right, children? Okay. Now, I will take this guitar. So, when we consider the guitar, which part should be vibrated in order to produce sound? Right? You all know this one as well. You all know that in order to produce sound, you all have to vibrate the strings of the guitar. Right? Now look at this guitar. If you observe carefully, you will see there are different types of strings. Right? You all can see this string is very, very thin compared to the other strings. Right, children? What about this? It is more thicker. Right? Okay, children? So, you can increase and decrease the stretchness, so the tension of the strings from this side. Right, children? Okay. So, listen to the sound. Now, you all know that in order to produce sound using this guitar, you have to vibrate the strings, and at the same time you can produce different sounds by vibrating different strings. Okay, now look at this one. When I vibrate this thicker string, one type of sound is produced. When I vibrate this thin string, the sound produced is different. Right? So, in between there are other strings. So, you all know when we vibrate these strings, different sounds are produced. Okay? So, at the same time, now look at this. I am going to vibrate this thinner string. That is the sound. Even that sound you can change by placing your fingers at different distances. See? Now without placing the fingers, now I'm going to place my finger over here, right? And when I place my finger over here, so even the same string, you can change the sound produced. However, in order to produce sound by these type of instruments with strings, now you know that we need to vibrate the strings. Okay? Right. Right, children. Now I will take the flute. So how do you produce sound using the flute, children? Now you all know that this is a tube-like structure. Right? You all can see there are different holes here. Right? This is where you have to place your mouth. And inside this tube-like structure, certain amount of air is trapped. So now you blow air using this small hole. What happens, children? The air trapped inside gets vibrated. Accordingly, sound is produced. Okay, children? And the sound produced using this flute can be changed by opening and closing these other holes. Okay, children? So now it's very clear these type of instruments. Now these type of instruments are known as wind instruments, right? So wind instruments produce sound by vibrating air trapped inside or air column. Okay, children? So after this activity, I hope it's very clear that there are different types of musical instruments and they produce sound in different ways. Right, children? It was a very easy activity. So if you have any musical instruments at home, you can try out this activity with them too. Okay? So observation, sound source, so instrument and part that vibrates. So what were the instruments we used? A guitar, a small drum and a flute, right? Let's write guitar, small drum, and we used a flute. So which part vibrates? When we produce sound using the guitar, what you have to do? You have to strum the strings. You have to vibrate the strings. Okay? So which part vibrates when we produce sound using guitars? The strings. part that vibrates its strings. Small drum, what do you have to do? You have to vibrate the membrane, right? Every drum has a skin or a membrane covering it. So you have to vibrate the membrane of the drum. So in order to produce sound, what part should be vibrated? The membrane. Flute, what happens? Inside the flute, an air column is trapped. So when you blow air into the flute, what happens, children? That air column trapped vibrates, right? So part that vibrates, air or air column. Right? So what is the conclusion after doing this activity? Different instruments produce sound by different methods, by vibrating different parts. Okay, let's write that as well. Different instruments produce sound in different ways. Right, children? Different instruments produce sound in different ways. Right? Okay. Musical instruments can be categorized according to the part that vibrates to produce sound. So there are three main groups of musical instruments based on the part that vibrates. Okay? The sound sources, vibration of strings. Now, next year also you are going to learn a lesson related to sound. Okay? So under this one you are going to learn there are three groups: vibration of strings and bars. I will explain you what are the instruments coming under the bar column. Right? Vibration of membranes, vibrations of air. Right? So now when you consider the xylophone, you have to vibrate the small metal bar. You have to strike with that special type of stick on the metal bar. Right? You must have seen the triangle. Triangle is a metal triangle. You have a part to hang like this. It's a metal triangle like this. And there's a small metal rod to strike on this. So when you play this instrument, which part vibrates, children? Now here given the strings, membranes and air columns. But this instrument does not have any of these things. So which part vibrates? That is the metal bar, metal piece. Right, children? And you must have cymbals. Cymbals, huge circular metal plates. There are two handles. Right? So in order to play this instrument, you have to vibrate the metal column or the metal bars, metal plate. Okay, children? So in that case, that group also can be included under one of these. Therefore, I will write here vibration of strings and bars. Because anyway, you are going to learn it in the upper grades. We will add it here itself. Vibration of strings and bars. So the instruments that we can play by vibrating strings: guitar, violin, sitar, banjo, harp. There are many other instruments like cello as well. Right? Vibration of membranes. There are different types of drums given here. This is known as double drum. Right? And here side drum is there, rabana is there. Right? Most of these drums are traditional drums. Right? Vibration of air. Vibration of the air column. What are the instruments played by that? Here different types of flute is given, right? Saxophone is given, French horn, clarinet. There are different types of instruments given here as well, right, children? So children who study, children who learn music as a subject, they know a lot about these type of musical instruments. There are special names given to these type of instruments. For example, The instruments that are produce sound by vibration of air columns are known as wind instruments. Likewise, right? These are known as string instruments. So there are special names also given according to the part that vibrates in order to produce sound. Okay, children? Right. So we have this assignment. Make a list of musical instruments commonly used. Mention the method of producing sound in each listed instrument, right? We will write some of these examples, including some of these examples. We can write the others as well, right? Sound sources. By vibrating membranes. By vibrating membranes. You all can start with me. Membranes. What are the instruments, children? We will write. Right. By vibrating membranes. And by vibrating air columns. By vibrating strings and bars. Strings and bars. Write some of the examples, children. Now I already mentioned some names. You can write the same examples. By vibrating membranes, different types of drums. We can write double drum, uthammattama, double drum. Then we can write bass drum, side drum, rabana, right? So you can write other examples too. The instruments that produce sound by vibrating air columns, we will write flute, saxophone, French horn, clarinet, right? You can write other examples as well, trumpet as well, right? By vibrating strings. First we'll write strings, violin, cello, guitar, harp, mandolin, right? Bass, you can write cymbals, and you can write triangle, xylophone. You can write other examples as well. Read books and find other examples too. As I told you all, children who study music, they know these, most of these examples they know. The other children, you can ask your friends who do music, and you can even read books and find more and more examples. Okay, children? We'll move on to the next. Okay, we have another assignment here. Listen carefully to some natural and artificial sounds heard in the environment and list them out. One is done here, school bell. Tabulate them as given below with the part that vibrates when producing sound, or method of producing sound. So you can even do this as a group activity, right? Get together with your friends, listen to the different sounds that heard in the environment, and you can write them down in a table like this, and you all can discuss that which part vibrates in order to produce sound. I will help you with some of these examples, okay? So school bell, which part vibrates, children? You all know that when you take the school bell, It's made up of metal. Even inside, a metal piece is there, metal rod is there. So you have to vibrate these two. When you strike this inner part against this outer part, what happens? It produces sound. So which part vibrates in order to produce sound, children? The metal surface, right? The metal surface. Metal surface. What are the other instances? We will write school bell. What are the other? Now here, some natural and artificial sounds. This is an artificial sound, right? Because this is an artificial object. We will write another artificial sound. Machines. So machines, how do they produce sound, children? Most of the time, most of the machine parts are made up of metals because of the contact of metal parts with each other, right? Because of vibration of metal surfaces, machines produce sound. Therefore, that also would be metal surfaces. Metal surfaces. What else, children? We can write wind blowing, or blowing wind, sound of the blowing wind. Blowing wind. So which part vibrates, children? In order to make sound, air particles vibrate with each other. Right part that vibrates is air particles. Air particles. Right? What else, children? Children talking. That's also a natural sound. Children talking. Right? At school, you can hear the other children talking. What is vibrated? Now you all know vocal cords vibrate. Right? Vocal cords. Vocal cords. So you can find many other examples. As I told you all, when you get together as a group, you can find out many other examples. Okay? Your friends will give so many ideas so that this will be very easy to complete. Okay? Not only that, when you do these type of activities, children, it improves your knowledge also, right? You get a better understanding about the lesson. Okay? So you get to discuss the subject matters with your friends. Okay? So thereby you can improve your knowledge. You can share your knowledge as well. Right. Okay, I did only a few examples, but you all have to find more and more examples too. Right, children? We'll move on to the next. Right. We have another assignment related to the production of sound. Okay? You may have heard of the sounds of some animals like mosquitoes, crickets, and honeybees. Right? You must have heard the buzz sound of honeybees. They always buzz. And the crickets are also very loud, even though these all are insects. Tiny creatures, sometimes like animals like crickets, they are very, very loud. Okay, children? Find out and record how they produce those sounds. Now, this will be a very good activity for you all to engage with, right? Because these examples, like how the sound is produced by these animals, not given in the textbook. Therefore, you have to read articles, right? You have to read more about these type of things in order to gain knowledge. Right, children? So, do you have any idea how these animals produce sound? Now, when you make a report like that, now find out and record how they produce those sounds. You can make a small booklet or a report. Okay, you can get the help of the articles published in internet as well, right? So, now when you consider honeybees and mosquitoes, how do they produce sound, children? Now, when you read, you will find more and more examples. I will briefly explain these things, okay? So, honeybees and mosquitoes, do you know that they produce sound? We get this buzz sound because of they beat their wings very fast. Because of the rapid beating of the wings, right? That's why they give out these special sounds, okay? So, mosquito and bees produce sound due to rapid beating of their wings. Okay, children. So the next one, crickets. Now, when you consider crickets, children, they have leather-like front wings. When they rub these front wings together, leather-like front wings together, a special sound is produced. Right, children? So not only that, some other insects also, like grasshopper also can produce sound by rubbing body parts. It can rub its hind leg with the margin of its wing. One of the hind legs, when it rubs with the margin of the wings, a special sound is produced. Right, children? So certain animals producing sound by rubbing body parts together is known as stridulation. Okay, so you can find many more information about these type of information about animals when you read more articles on this, right? We will write cricket. It produces sound by rubbing leathery front wings. Right, children? And again, grasshopper. It produces sound by rubbing a hind leg with its wing. Right? So there are special ways they produce sound. There are special reasons for the production of sounds too. Right? So when you read more about these type of information, you can improve your knowledge. So we have completed the first chapter of this lesson. Now under this chapter, we learn about production of sound. Now we know that sound is produced by vibration of objects, and we learn some special methods of producing sound by musical instruments too. So in the next chapter, we are going to learn about propagation of sound.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.